Okay, so welcome to 3.3, which is the unit circle. The unit circle. Okay, but before we begin with that, let's recall. So in a 30, 60, 90, 30, 60, 90 right triangle, the ratios of side, so the ratios of small side to long side to hypotenuse are given by the ratios of 1 to the square root of 3 to 2. Remember that? So what I'm going to do is I'm going to take this ratio, actually let me move this a bit to the left. So let's take this ratio, copy it and paste it. And what I'm going to do to each of these, I want to divide each side by 2 because I want my hypotenuse to be 1. So what this gives us then is 1/2 to the square root of 3 over 2 to 1. I want the hypotenuse to be 1. So, and if you're savvy, you might recognize some of these numbers from when we were doing our trig charts, but don't worry about that. So 1/2 to root 3 over 2 to 1 is the ratio if the hypotenuse is 1. Also, we had what? We had in a 45, 45, 90. So in a 45, 45, 90 right triangle, the ratios of side to side to hypotenuse, the ratios of side to side to hypotenuse, side to side, remember both sides are the same here, to hypotenuse, are given by that was 1 to 1, 1 to 1 to the square root of 2. So in that case, if I wanted to get 1 for the hypotenuse, I would have to divide each of these ratios by the square root of 2. So let's go ahead and do that. So I'll divide each side by the square root of 2. So rationalizing, multiplying top and bottom by the square root of 2 would give us square root of 2 over 2, which is equivalent to 1 over root 2. Square root of 2 over 2, because both sides are the same. And hypotenuse of 1, which is what we're going for here. So this is the ratios in a 45, 45, 90 right triangle, provided the hypotenuse is 1. So definition, what do I mean by unit circle? Unit corresponds to 1 of something, right? So 1 of what? So definition, the unit circle has 1 of something, because unit means a single 1. So, and we denote the unit circle in mathematics. So denoted by capital S1, which in math means a sphere of one dimension, so denoted by S1, so is the circle of radius 1. So there's our unit. So is the circle of radius r equal to 1. So because the radius is 1 unit, that's why we call it a unit circle. And the center is at the origin 0, 0. So I've got a circle, 0, 0, not 1, 1, 0, 0. So I've got a circle centered at the origin of radius 1 unit, hence unit circle. So let's note so for all, that's an upside down A, so for all points, let's call them x comma y, on, so is an element of or on the unit circle S1, this implies that x squared plus y squared is equal to 1. Okay, so because our radius is 1, so 1 squared is 1. So let's recall. For triangle trigonometry, we had that sine of an angle theta was y over radius r. So that's just going to be y over 1 if I'm on the unit circle. Now cosine of an angle theta was x over the radius r, which is just going to be x if I'm on the unit circle. However, tangent of theta is still y over x. It doesn't matter if I'm on the unit circle or not. So, what does this mean? These together imply for all points, so for all points x comma y, x comma y on the unit circle corresponding to theta, corresponding to theta in standard position, standard position. This implies that the point x comma y is really, well, what is x? It's cosine of theta, right? And what is y? Well, it's sine of theta as long as I'm on the unit circle. Right. So let's consider. Okay, so what I'd like to do is I'd like to draw 3 x and y coordinate axes. So let's go ahead and draw one and then copy and paste it. 1. I don't know if that's even. Is that even? Let's see if I did it right or not. So x and y. 1, 2, 3, 1, 2, 3, 4. Nope, I always seem to get it wrong. That looks a bit better. And let's draw a circle. Hopefully it'll auto-correct. Wow, this is a terrible circle. One of the worst circles I've ever drawn. Let's see. I can draw it a bit better. Yeah, there we go. Okay. That looks somewhat okay. Let me make it a bit better. Okay. So I'm going to copy and paste this 3 times. So assume that this is my unit circle. I'm just going to look at 3 different things here. Oh, no, that's not on the line. Okay. So first I'd like to look at the 30 degrees. Let's look at 30 degrees. So say I've got an angle of 30 degrees. Okay. Well, on the unit circle, that's going to be cosine of 30 degrees, sine of 30 degrees. Okay, so what is cosine of 30 degrees? Well, if I look at this, it looks like the x-coordinate is larger than the y-coordinate. So I'm going to go with... Wow, okay, why is that not working? It autocorrects to where I don't want it to be. Yep, okay. Okay, I guess that is where it should be. Okay, so I claim that cosine of 30 degrees is the square root of 3 over 2. And why is that? Well, because I'm in a 30, 60, 90 right triangle. Okay. Comma. Let's go ahead and do the y-coordinate in yellow, shall we? So this will be 1/2. Okay. Well, what's interesting is if I look at the reference angles in each quadrant, meaning I'm always 30 degrees away from the x-axis. So I'll create a whole bunch of little triangles here. Did that not work out? Did I do that a bit wrong? Shoot. Let's see. Maybe I'll erase this one, bring this down so I know where it's going to intersect. Okay, so I'm going to draw from here through the center, like so. Okay. So if all of these are 30 degrees away from the x-axis, so 30 degrees here, 30 degrees here, these are all 30-degree reference angles, then what do I know? I know that the coordinates should be almost the same. So this coordinate in quadrant 2, the x-coordinate is negative. So it's negative root 3 over 2, comma, still positive 1/2 for the y-coordinate. In quadrant 3, they're both negative, so negative root 3 over 2, comma, now negative 1/2 for the y-coordinate. And in quadrant 4, my x-coordinate is positive root 3 over 2, but now my y-coordinate is negative 1/2. Okay, hopefully, might need to move this a bit closer. Need more room here. Oops, no, that's not what I wanted to do. Undo. Okay, let's see if I can shift this. No, I probably can't. Okay, let's see what I can do here to give myself a bit more room. Maybe that'll work. Okay, so this is my unit circle here, and these are all the points that are at 30 degrees. So 30 degrees reference angles on the unit circle. Okay, now let's look at 45-degree reference angles on the unit circle. So those are easier for me to draw because they're the main diagonal, especially with autocorrect. Okay, so the 45-degree reference angles create 45, 45, 90 right triangles. So I know both x and y have coordinate root 2 over 2. If my hypotenuse for each of these triangles is 1. So once again, I'm looking at the hypotenuse here. Or sorry, these are not the hypotenuse that I'm drawing, but the hypotenuse is in orange. And imagine, if you will, that these are actually on the circle. Okay, so what are the x and y coordinates here? Well, x is root 2 over 2. But y is also root 2 over 2. So let's do that in yellow. In quadrant 2, x is negative root 2 over 2. But y is positive root 2 over 2. And in quadrant 3, they're just both negative, so negative root 2 over 2, comma negative root 2 over 2. And finally, in quadrant 4, the x-coordinate is positive root 2 over 2, and the y-coordinate is negative root 2 over 2. Okay. So these are 45, 45, 90 right triangles in each quadrant. The hypotenuse is the radius, and I know the radius on the unit circle S1 is 1. So hence why I got 1 for each of these. So I knew how to write the other two. Okay, what's the next one? 60 degrees, right? So let's do 60 degrees. What color shall we use? How about pink? So let's do something like so. Yeah, does that look like it's okay? Something like that. I don't know, it's hard to tell. Hopefully I did this right. Kind of. Okay, so once again, let's draw these guys. So I have created 4 60-degree reference angles, so 60 degrees here, 60 degrees here with respect to the x-axis, 60 degrees here, and 60 degrees here. So I want all 4 60-degree reference angles. Okay, so we have 4 points on the unit circle. We know the hypotenuse, which is in pink, is 1. So now in a 30, 60, 90 right triangle, the x-coordinate for these guys is smaller. That's a 1/2, which means the y-coordinate is the larger guy, root 3 over 2. So I just need to use this point and change the signs depending on the quadrant. So in quadrant 2, x is negative 1/2, but y is still positive, root 3 over 2. In quadrant 3, they're both negative, so negative 1/2, comma negative root 3 over 2. And finally, in quadrant 4, x is positive 1/2, but y is negative root 3 over 2. Okay, so that's a lot, but hopefully that makes sense because these are either 30, 60, 90 right triangles. So we have short side 1/2, long side root 3 over 2, hypotenuse 1, or 45, 45, 90 right triangles, in which case x and y are both the same, meaning sine and cosine, right? Okay, so let's recall a couple things. So recall. 2 pi radians, which is 2 pi r, is a full circumference, meaning it's equivalent, let me write equivalent better. 3 lines for equivalent to 360 degrees. It's full circle. So dividing this by 2, half a circle, of course, is equivalent to 180 degrees. Dividing that again by 2, pi over 2 is equivalent to 90 degrees. And again by 2. Pi over 2 is equivalent, pi over 4. 2 times 2 is 4 is equivalent to 45 degrees, but I'm missing a couple. So let's go off to the side here and do these. Let's do, what color should I use? Dark purple. So if I divide pi by 3, so let's put that here, pi over 3, instead of dividing it by 2, 180 divided by 3 is 60. Okay, so there we are. Now let's divide that again by 2. So that's pi over 6. That's equivalent to 30 degrees. Okay, so hopefully we know how to get those, just dividing the circumference. So let's consider again and y coordinate axes, and I'm going to draw a unit circle on it, but this time I'm going to make it a bit larger. Let's see. Kind of hard to see here. Nope, I always seem to do this too long on the Y. Okay, maybe that looks okay. So Y and X. Let's go ahead and I'll draw a small circle and then change its sides. So I'll move this over here and make this a bigger circle. There we go, that looks okay. Make this a bit smaller. Come on, nope, okay, it's not gonna let me do this. Thank you, Apple. Okay. So I want to fit two of these side by side. So let's assume that this is my unit circle, S1. And I'll copy this and paste it over here. Copy, paste. So I'll have another one over here to deal with in a bit. Okay. So first what I'd like to do is I'd like to count up. I know that, let's see, let's count up by multiples of 30. Okay. So we're starting at 0. But now if I go to 30 degrees, which I know is equivalent to, okay, why is that not working? There we go. So 30 degrees is pi over 6 radians. Now if I add another 30 degrees, oh boy, this is not done very well, is it? Okay, well, I'm trying. So let's say I have 2 times pi over 6. Well, 2 times pi over 6 is how much? That's pi over 3s, right? Now let's go up here to, maybe I'll do this as orange. If I'm here, 3 times pi over 6. This is 3 times pi over 6. So that becomes, let me move this S1 out of the way. So that's just pi over 2, which I know is 90 degrees, so that makes sense. Okay. Now let's do four times pi over 6. So 4 times pi over 6. So the 2's reduce, and this leaves us with 2 pi over 3. Okay, here. Make sure I've put the dots so we know where we are. Okay, now let's go to for 5 times pi over 6, which is just that, 5 pi over 6. So there's nothing I can do there. Let me write that a bit better. So 5 pi over 6's. That does not reduce. Now let's go to 180 degrees away, so that's 6 pi over 6's. So 6 pi over 6. Of course, that reduces to pi, which is exactly what it is. 180 degrees, right? I've gone half a circle. So I'm counting up by pi over 6's here. In fact, let me move this guy a bit so we see that that's at 90. Okay, so now where are we? 7 pi over 6s, right? Let's put a bigger dot here. So now I'm at 7 pi over 6s here, which does not reduce. So it's just 7 pi's over 6s. Now the next one would be 8 times pi over 6, both of which is divisible by 2. So what we get then is 4 pi over 3. Then we're back down here at 270, which is 9 pi over 6s. 9 times pi over 6, both of which is divisible by 3. So doing that would be 3 pi over 2 down here. The next one would be 10. How do I want to write this? 10 times pi over 6, once again, both of which is divisible by 2. So that's 5 pi over 3. Here down here at this angle, it's a 5. It's hard to see. Let me write that a bit better. So 5 pi over 3s. And finally, 11 pi over 6s, nothing reduces. So there we are. And we could go full circle to 12 pi over 6s. So 12 pi over 6. 6 goes into 12 twice, so that's 2 pi, which is full circle. Okay, so now let's count up. Instead of by 30s, let's count up by 45s, which are easier because there's less of them. So let's go ahead and move this here. Okay, so 45, what color did I have? I had yellow, but let's do it in gold. That'll be easier. So we'll count up by 45s. So I always start at 0, but I'll come back to that. So let's start at the first 1 times 45, which is pi over 4. Now if I go to 2 times pi over 4, up here, so this is, actually let me change these colors to a lighter yellow just so we can see the difference. It's far too close to the, no. What? That's weird. Okay, so let's call this brighter yellow. There we go. Now hopefully we can see the difference, because if I have 2 times pi over 4, this reduces, and it should be the same as when I counted up by 30s. Is this pi over 2? It is. So it's still 90 degrees. Now let's keep on counting. This is 3 pi's over 4. If I have 3 45s, that does not reduce. Then next I have 4 pi's over 4. Well, of course, 4 pi over 4, the 4's reduce, and I'm left with pi, as I should be, because that's 180. Okay, let's keep on counting up. So the next one will be 5 pi over 4, which does not reduce. Then counting again, 5, this will be 6 pi over 4, so 6 pi over 4, each of which is divisible by 2. So that gives us 3 pi over 2, which is good because that's exactly what we had for the other one. And last but not least, let's do, or not last, 7 pi over 4 doesn't really reduce. And coming full circle, we have 8 pi over 4, which of course 4 goes into 8 twice, so this is 2 pi. Check mark. Okay, so this is counting up by 30 degrees and 45 degrees. So from this we can create the unit circle. So let's create the unit circle. because each of those was a circle of radius 1. Okay, so x and y coordinate axes. So x and y. And now let's create a large circle. Start off with a small circle. Bring this over here and make it larger. Oops, no. Why is it not on? There we go. Okay. Okay, so let's do our 45s first. Those are the easiest to draw because they're along the main diagonal. Okay, now let's do the 30 degrees next. And now we'll do the 60 degrees. Oops, what's going on? Let's undo that. Why does it keep on auto-correcting there? Okay, let's start down here then. Go up this way. Okay. Oops. Wow. It really does not want to work with me today. I don't know why. Okay. And then, of course, we have the 90 degrees. So let's do that here. And then let's do this in darker red. Pies. Okay. So let's start off with the 30-degree reference angles. So each of these is a pi over 6. So pi over 6. Then notice we have these two guys are the pi over 6's, 5 pi over 6 on top. Then on the bottom we had the 7 pi over 6 and the 11 pi over 6 for the 30-degree reference angles. 7 pi over 6, 11 pi over 6. And now let's go to the, guess I have to use a light one. So the pi over 4s. So we have 1 pi over 4 here. Oops, 3 pi's over 4 here. 1, 3, 5 pi over 4 here. And then 7 pi over 4 here. Now we'll look at the 60-degree angles, which are higher up, so pi over 3 and 2 pi over 3. Now this is not drawn very well, but you get the idea. Pi over 3 and 2 pi over 3. Then looking at the bottom two, it's 4 pi over 3 and 5 pi over 3 on the bottom. So 4 pi over 3 and 5 pi over 3. Now let's look at the 90-degree reference angles. The pi over 2's, so here is pi over 2. Then beneath it is 3 pi over 2's. Now we can look at the 180's. So the 180's are pi and 2 pi, or 0. Full circle. Okay, but wait, we're not done yet. So what I'm going to do, remember for a 30, 60, 90 right triangle, this has x coordinate long, y-coordinate short. Over here we have negative x-coordinate long, positive y-coordinate short. Over here we have negative x-coordinate long and negative y-coordinate short. Then over here we have positive x-coordinate long and negative y-coordinate short. For the 45-degree reference angles, we have, both of them are the same. They're both root 2 over 2. In quadrant 1, they're both positive. In quadrant 2, x is negative. I don't like the way that root 2 looks. In quadrant 3, they're both negative, so negative root 2 over 2. Come on, negative root 2 over 2. And in quadrant 4, x is positive, root 2 over 2, but y is negative root 2 over 2. Now let's look at the 60-degree reference angles, which once again are 30, 60, 90. So now the x-coordinate is the short guy, and the y-coordinate is the long guy, root 3 over 2. In quadrant 2, it's negative short coordinate 1/2, positive root 3 over 2. In quadrant 3, they're both negative, so negative 1/2, comma, negative root 3 over 2. And in quadrant 4, it's positive 1/2, but negative root 3 over 2. Okay, now let's look at the 90-degree guys. So on the unit circle, this is going to be 0 for x, 1 for y. That makes sense. Down here, it's going to be 0 for x, negative 1 for y. Now looking at the 180-degree ones, we have at pi, this is going to be negative 1 for x, 0 for y. And at 2 pi, it's 1 for x, 0 for y. So this is the unit circle. All of these quote angles with all of these points. And in fact, I'm going to move this down a bit. Oh shoot, I don't know if I have enough room to do that. Okay, well hopefully this isn't too cramped and you're able to see this. Okay, so let's see if I can force an example in here. Maybe if I move this up a bit. Okay, so let's use this unit circle, which you are free to use. So example, let's evaluate the 6 trigonometric functions. So these 6 trig functions of theta equals to, how about let's do 5 pi over 4. So that is going to be this angle right here. Okay, so sine of 5 pi over 4 is going to be the y-coordinate at 5 pi over 4. In fact, let me color code this. Let's make this yellow. So the y-coordinate is negative root 2 over 2. Cosecant, the reciprocal, so cosecant of 5 pi over 4. Well, flipping 1 over root 2 upside down is just negative root 2. If I unrationalize. Okay, so now cosine of 5 pi over 4 is going to be the x-coordinate there. So the x-coordinate is also negative root 2 over 2. Negative root 2 over 2. Okay, so flipping this upside down for secant, we get the same thing as cosecant. So secant of 5 pi over 4 will be negative root 2. And cosine, actually let me do this in this color. Cosine of 5 pi over 4, not cosine, what am I saying? Tangent of 5 pi over 4 is just the quotient of the two above him. Okay, so if I take the quotient of two things that are equal, I get 1. Doesn't matter how ugly they are. The reciprocal function, cotangent of 5 pi over 4, 1 over 1 is 1. Okay, so there we are. Those are the 6 trigonometric functions using the unit circle. So let's do a couple more. So, example. So use the unit circle. The unit circle to evaluate these 6 trigonometric functions. So the 6 trig functions at the following values of theta. So number 1, let's do theta is equal to 11 pi over 6. How about that? 11 pi over 6. Okay, 11 pi over 6. Where is that? Oh, there it is. 11 pi over 6 is x is root 3 over 2 and y is negative 1/2. Okay, so let's note that. So this implies that we're at root 3 over 2, comma negative 1/2 on the unit circle on S1. Okay, so therefore sine of 11 pi over 6, which is the y coordinate, is going to be negative 1/2. So right away we know that cosecant, the reciprocal, cosecant of 11 pi over 6, which is 11 times 30, right? Because pi over 6 is 30, so that's 330 degrees. So that's going to be negative 2. So cosine of 330 degrees, or 11 pi over 6's, is going to be the x-coordinate, which is root 3 over 2, which means that secant, which is the reciprocal, secant of 330, or 11 pi over 6 radians, is just going to be unrationalized. It's going to be 2 over root 3. Let's do tangent in green because I already used pink. So tangent of 11 pi over 6. Tangent is the quotient of the 2 guys above it. So the 2's reduce and I'm left with negative 1 over root 3. So now taking the reciprocal for cotangent. So cotangent of 330, which is 11 pi over 6, gives us a negative square root of 3. Okay, subscript number 2. Let's say we have that theta is 4 pi over 3. How about that? I didn't use that already, did I? So 4 pi over 3. So where is 4 pi over 3? 4 pi over 3. Okay, so I'm at negative 1/2, negative root 3 over 2. Okay. So this has a coordinate of negative 1/2, negative root 3 over 2 on the unit circle. On the unit circle. Okay, so we can go ahead and evaluate our 6 trigonometric functions. So sine of 4 pi over 3, which is the y coordinate, it's going to be negative root 3 over 2, which means the reciprocal cosecant of 4 pi over 3. So 4 times pi over 3, so 4 times 60. What is that, 240 degrees? So that'll be negative 2 over root 3 if I don't rationalize, which I don't mind if you don't. So now cosine of 240 degrees, or 4 times 60 degrees radians. So this is going to be the x-coordinate, which is negative 1/2. So that means that the reciprocal function secant of 4 pi over 3 is just going to be negative 2. Tangent of 4 pi over 3 is just the quotient of the two above. So the 2's reduce, the negatives reduce, and I'm left with root 3, which means that the reciprocal cotangent of 4 pi over 3, well, that's just going to be 1 over root 3. That's interesting. Okay, so number 3. Let's say we have theta is pi. So on the unit circle, we're here at the point -1, 0. Okay, so this is the point -1, 0 on the unit circle. So sine of pi is the y coordinate, which is 0. So that means that the reciprocal function cosecant of pi, thou shalt not divide by 0, does not exist, DNE. Thou shalt not divide by 0. Okay, so cosine of pi, well, that's the x coordinate, which is -1. So the reciprocal function secant of pi is also -1. Tangent of pi is the quotient of the two above him. 0 divided by -1 is 0. However, when I take the reciprocal function cotangent of pi, once again, thou shalt not divide by 0, so I know that this does not exist. DNE does not exist. Okay, how about one more for good measure? I know third time's a charm, but let's do another quadrantal angle. How about 3 pi over 2? So now we're down here, 3 pi over 2, which is 0, -1. That's an orange, pardon me. Okay, so this is 0, -1 on the unit circle. So we have that sine of 3 pi over 2 is the y coordinate at that angle, which is -1. So the reciprocal to sine cosecant of 3 pi over 2. So pi over 2 is 90, so 3 pi over 2 is 270, right? So this is going to be also -1. Cosine of 3 pi over 2, on the other hand, is the x coordinate. So that's going to be 0, which means that the reciprocal function secant of 3 pi over 2, well, we know that thou shalt not divide by 0, so I know that this does not exist. So finally, we have tangent of 3 pi over 2, which is 270 degrees, 390s. Well, it's dividing by 0, right? 0 is in the denominator, so I know that does not exist. But how do I take the reciprocal of something that does not exist to get cotangent of 3 pi over 2? Well, instead of taking the reciprocal, I know that cotangent is x over y. So x is 0, y is -1. So 0 over -1 is 0. And there we are, and I will see you guys in the next section.